Good day, students. The topic we are treating today is energy quantization. The history of a man named Max Planck was able to show experimental observation on the radiation emitted by a substance could be explained on the basis that the energy emitted from the metal surface could be in discrete or separate packet of energy called HF, where H is the Planck constant, while F is the frequency of the emitted electrons. And it was able to also tell us that energy can jump to higher level when it's being excited, when it's in the excitation state, and it doesn't remain on the excitation state because it's unstable. It can jump to the ground state or to any energy level. Now, in 1902, Max Planck was able to show that experimental observation in the radiation emitted by a substance could be explained on the basis that the energy from such a body is emitted in separate or discrete packet of energy known as energy quanta of value HF. Where F equals frequency of radiation and H is Planck constant, thus the energy E of one quantum of radiation or photon E equals HF. Take note. This is known as Planck's theory of radiation. The term quantum means fixed amount or discrete or separate amount. Fixed amount, discrete or separate amount, as distinguished from a continuous quantity. To be able to measure our values, it has to be in discrete amount, and this is how energy was being emitted from the substance as a quantum energy. Okay, now the electron possesses higher energy as long as it remains in the excited state. Because excited states are unstable, the electron soon jumps back to its original orbit or energy level and emits a photon or quantum of light with a characteristic frequency or wavelength. In the process, according to the relation, please take note of this formula: En minus E naught equals to HFN. Frequency velocity C equals to F lambda. You can replace this F now will be C over lambda. You now replace F with C over lambda, where En equals energy in the excited state, E naught is the energy in the ground state, where N equals to 1. N equals to 1. Not all jumps are to the ground state or ground level. Electrons can also jump from one allowed energy level to a lower allowed energy level. Now we'll move into calculation to see how it's been applied in solving problem. And the first thing to do is to write the parameters. Change in energy equals En minus En. We call M to be any medium of the jumping, but it's not specified because of HF. Don't forget that your C, which is velocity, you can use C or V, or under energy quantization we use C. Equals to F lambda. Now F equals to C over lambda. Now go back, substitute equals H C over lambda. Now let's see what are the parameters given to us. Change in energy is 4.5 times 10 to the power minus 19 joules. Planck constant H equals 6.6 times 10 to the power minus 34 joules seconds. What is the wavelength of the radiation? You are given the velocity C equals 3 times 10 to the power 8 meter per second. Now let's go to our formula. Delta H, which is 4.5 times 10 to the power minus 19 equals h 6.6 times 10 to the power minus 34 times what our c 3 times 10 to the power 8 divided by wavelength, cross multiply. You have 4.5 times 10 to the power minus 19 wavelength equals 6.6 times 10 to the power minus 34 times 3 10 to the power 8 divided by 4.5 times the power minus 19. Now you have wavelength to be wavelength. When you press the calculator, press this together before dividing with this. Now, final answer, when you divide it, you have 4.4 times 10 to the power minus 7 meters. Multiply the above, write the answer, divide it. When you are dividing, put brackets. Put this one inside bracket so that it go along with upper one at the numerator. It is meters. Write the parameters. Said that when you mention quantum of energy, that's still referring to the photon of energy, and quantum means separate, discrete. Quantum of energy, separate or discrete. Now let's not say energy E2 energy level equals minus 2.42 times 10 to the power minus 19 joules. The ground state E0 minus 21.8 times 10 to the power minus 19 joules. Calculate the frequency and the wavelength. We are given h, Planck constant, 6.6 times 10 to the power minus 34 joule seconds. Now, change in energy, so E2 minus from the ground state equals HF. Now, since we are given these two energy level, we are going to subtract them, which is minus 2.42 times 10 to the power minus 19 minus open bracket another negative that's 21.8 times 10 to the power minus 19 close the bracket equals to what is the Planck constant 6.6 times 10 to the power minus 34 joule seconds F divided for the let's solve this minus 2.42 times 10 to the power minus 19 minus times minus is positive 21.8 times 10 to the power minus 19 equals 6.6 times 10 to the power minus 34 F. When you add 21.8 minus this, when you press your calculator very well, press this one first, 21.8 times 10 to the power minus 19, open the bracket and put minus. What I'll say that let's change it, that'll be 21.8 times 10 to the power minus 19 minus 2.42 times 10 to the power minus 19 plus 6.6 times 10 to the power minus 34 F. When you are pressing your calculator, when you put minus, open the brackets and put the value, close the bracket. When you press your calculator very well, you get 19.38 times 10 to the power minus 19 equals 6.6 times 10 to the power minus 34 F divided by 6.6 10 to the power minus 34 right 6.6 times 10 to the power minus 34 cancel this. F frequency equals 19. F equals it, when you divide it, you have 2.94 times 10 to the power 15 hertz. That's the frequency. Now we have to look for the wavelength. Don't forget that your C equals F lambda. You are looking for wavelength. Your wavelength now equals to C over F. Now C now wavelength equals what our C? I give C. C is 3.0 times 10 to the power 8 meter per second. Just take note of that. C equals to 3.0 times 10 to the power 8 meter per second. Now your C, 3 times 10 to the power 8 divided by what's our frequency? 2.94 times 10 to the power 15. 10 to the power 15. When you divide it, press this one separate in your calculator. When you are dividing it, let it be in brackets before you divide. Let's take everything together. Now when you get that, the final answer for that is 1.02 times 10 to the power minus 7 meters. That's the wavelength. This is the end of our class. Please subscribe to my channel so that you get the latest video. Have a nice day.